At the end of this week, you guys are going to have a test. I don't know if it's going to be on Friday or if it's going to be on Monday, and it's going to be solely over factoring, okay? Factoring just plays a huge part into what is coming for you guys. If you're going to continue on in math, factoring is going to play a huge part in that. But simply put, also, the very next unit that we're doing, which is just the rationals. Remember, rational functions look like 1 over x, to some extent, something like that, right? When we start solving and problems with rationals, what you're going to find is you're going to have to factor everything on the top and on the bottom and get things to cancel out. And where things cancel out, you'll have like things, and we're going to learn about all this next week, called removable discontinuities. You're going to have vertical asymptotes, you're going to have horizontal asymptotes, but vertical asymptotes and removable discontinuities all come from your ability to factor well and cancel things out, okay? So that's why we're going in depth with factoring right now. Everybody good with that? So you need to know this not only for the very next unit, because truly, if you don't understand factoring on the next unit, you're not going to do well. But you also just need to know it if you're going to continue going on in upper level maths. Factoring is just huge, okay? So I've already shown you how to factor a lot of things. You should be looking at a flow chart right now, and the top of the flow chart, it consistently starts off and it says, does a greatest common factor exist? So I've grouped these 3 screens right here by trinomials, factoring binomials. So binomials, you can have the difference of squares, you can have the difference of cubes, the sum of cubes, okay? And then factoring by grouping, which is when you factor something with 4 or more terms, okay? So, quick review on trinomials. It's pretty easy stuff, but let's just start off. And you guys are going to need this. I mean, it's on the other side of your sheet. Also, you've got all this space on the right side. Those lines are simply for you to take notes, okay? So if you want to take notes there, that's fine as well. But you're going to consistently be referencing this. I will not be. Okay. So, at the top, does it have a greatest common factor? Let's look at this left side right here. Does that have a greatest common factor? Yeah, what is it? X. And this should look familiar to you guys. I'm not sure how many of these we solved already, but the day I explained this to you, we went through a lot of these, okay? So yeah, it has an X. Okay, so the very first thing you're going to do when you're factoring is you're going to try to pull out a greatest common factor. So in this case right here, we're factoring this one, it has an X that can be factored out or divided out. So the way you know that is you look at every single term and you ask yourself, are there any variables that they have in common? Yeah, they all have an X, at least one X, right? So we're going to pull that one X out, and then you also look at the coefficients. Okay, so this has a 1, -2, and -24, and really those have nothing in common other than the number 1. So you're just going to leave it. Okay, so when you factor out an X from X cubed, you had 3 X's, now you have 2. You had 2 X's, now you got 1. You had 1x, now you don't have any at all. And then whatever is left in here is what you're going to be factoring still. Okay, so we have a trinomial. So if you're looking at that flow chart, the next question asks, it says, does it have 2 terms? No, it does not. Okay, so you follow the no down, and the next question is, okay, are there 3 terms? Yes, it has 3 terms. 1, 2, 3 terms. Simply put, remember a term is anything that is separated by a plus or a minus sign. Okay, you guys good with that? So we have 3 terms here. Real quick question that doesn't matter too much. What's the degree of this function inside that we're factoring? What's the degree of this expression on the inside? Yeah, it's degree 2. Remember, it's squared. That's just a random question that you guys need to know. You need to be able to identify this stuff. Okay, and we have 3 terms. Any questions on that? Okay, so now factoring a trinomial, first thing you want to notice is that the number in front is 1, okay? If it's not 1, then hopefully you were able to factor it out. Like in this next example right here, we're going to factor out that 2. And you're going to be left with 1 in front, okay? So right here we have 1 in front, and that makes it really easy. If you have 1 in front on a trinomial, then you're looking for 2 numbers that multiply. Remember, this is A, B, and C. 2 numbers that multiply to be the C part, that -24, but add to be the B part, -2. So what are 2 numbers that multiply to be -24, add to be -2? 6 and 4. So which one needs to be negative? Because they have to add to be negative 2. Negative 6, positive 4, right? So when it's finished being factored, it looks like x minus 6 times x plus 4. Negative 6 times 4 is negative 24. Negative 6 plus 4 is negative 2. So that's all factored, and you still have the x on the outside. Are we good there? Should all be complete review for you guys. Which means on the next one, I'm going to work through it a lot quicker. Okay? We're good so far? All right. So, not to, I guess the term is beat a dead horse, but what's the first thing I need to do here if I'm going to factor it? Yeah, divide it by 2 and take out 4 m's. Or just pull out the GCF, right? Pull out the GCF. And that's what I was going for. But yes, that's exactly what we're going to be doing. So she noticed the GCF. When she's looking at all the numbers, it has a 2 that can be pulled out.
All students should be in their second semester class at this time. All students should be in their second semester class at this time. From this point forward, if they are not there, please count them tardy.
All right. So, and then you have m to the 4th. So every single one of these terms has at least 4 m's that it can give up. So we're going to pull 4 m's out of all the terms. So left over on this one, we're going to have just simply m squared, 2 m's, minus, now 24 divided by 2 would have been negative 12. Okay, and then we had 5 m's, so we have an m left over. And then this one divided by 2 is going to be 32, and then we pulled the 4 m's off, so we don't have any m's left over. Everybody good there? Okay, so the value of a is 1, so we're looking for two numbers that multiply to be 32 and add to be negative 12, should be negative 8 and negative 4. Negative 8 times negative 4 is positive 32, and negative 8 minus 4 is negative 12, and that's factored. Notice something that's going to tie into factoring by grouping. Notice that when something has been factored, everything is being multiplied, right? All these, sometimes binomials, sometimes monomials, right? But everything is, to some extent, multiplied together. Does that make sense? There's no pluses in between, the parentheses, making every single thing dependent on something else being multiplied by it. Okay? We're good with that? Okay, one last one on the trinomials, and this is all review right now. And you can take this, I realize it's written at the bottom of your page, you can write it to the right on those lines to solve it out, or you can solve it right there if you think you have enough space. All right, so GCF, first thing, GCF. So Jacob, what's the GCF here? Yeah, 4 R's. Okay. What about the numbers? 3, 11, 20, anything in common? Nope. Okay, so let's pull out R to the 4th power. So we're going to have 3R squared minus 11R minus 20, all left over. Everybody good with that? The reason I wanted to do this one is because when you look at this trinomial that's left over that we still need to factor, your A value is not 1 anymore, right? It's 3. Okay. And notice they have nothing in common. So you're going to have to actually, well, let's see if anybody remembers. How do we factor this one? Go for it, Madison. Yeah, so it's A times C, so you're going to do 3 times negative 20, which is negative 60. And you're going to find factors of negative 60 that add up to negative 11. Okay, so if you're not very good at this, you can start writing out factors of 60. So 1 times 60, 2 times 30, 3 times 20, 4 times 15. And that one looks like it's going to be the one that works. You can continue writing them out if you want to, but 4 times 15 looks like negative 15, positive 4 would add up to negative 11 and multiply to be negative 60. So you're going to have this part factored out is going to look something like this. It's going to be R minus 15 times R plus 4. Now I said something like this because, anybody remember what it's missing? Yeah, you got to divide by what? By what? What number? 3. Okay. So make sure because you multiplied that negative 20 by 3, you actually have to remember to divide by 3 right here, okay? Now you reduce these fractions down as far as you possibly can, and if they can't reduce any further, then you go ahead and place the denominator up in front of the r. So we have r minus 15 divided by 3, so we have r to the 4th, and then r minus 15 divided by 3 is 5. So that's good. And then this one can't be reduced any further, so I'm going to swing the 3 up, and that would be completely factored. Okay, should be all review so far. Got it? You guys should be beasts at trinomials by now. Okay. All right, so there's that. And guys, make sure you're writing down really good notes, because what you're going to do in a second, and here's your homework assignment. I guess I'll just say it while we're recording. Your homework assignment's going to be this page 236. 236 right here. And I know you don't all have your books. I actually counted them. They're over there. So we'll get them in a second. But it's going to be on page 236. And you're going to do numbers 5, which we've done maybe a third of the problems already at some point. We're going to do numbers 5 all the way through number 54. And you're going to have 3 days to do it, counting today. So today, you're going to work on it tomorrow. You're going to work on it Thursday. And we're going to do all of them. Okay? 5 through 54. And you can do them at home if you wish. But what I'm telling you, once you do like probably 4 of each type, you're going to start getting real quick with them. A lot quicker. Okay? But I figure if you can do numbers 5 through 54, you're going to know what you're doing pretty well. All right. Questions about trinomials? We're good? All right. Now, what I want you to look at is when you're looking at this flow chart, again, what we've learned how to do now is going from the top where it says, does it have a greatest common factor? If yes, we factored it out. Does it have 2 terms? No. Does it have 3 terms? Yes. So we know how to do anything with 3 terms now. Okay? We know how to do this whole area. Now, again, we're going to focus on 2 terms. So what does it look like if you are factoring something with only 2 terms? All right. So it starts off the same way. Does it have a greatest common factor? So let's do this first one. Does that have a greatest common factor? 4, and then how many k's? 3. Okay, so when we factor it out, we have a 4. Both 4 and 100 are divisible by 4. And then we have k cubed that we can factor out. So we're going to be left with k squared minus 100k cubed divided by 4k cubed is going to be just 25. Okay, and again, I taught this probably, I don't know, it was before we went on break though. Was it before we went on break? Everything's gotten so merged together, I feel like. Anybody remember what that's called? What's left in the parentheses? What was it? Difference of squares, right? So k squared, and then what is 25? It's what squared? 5 squared. So it's the difference. Notice it's the difference of squared. If it was a plus sign here, if that was a plus sign, you can't factor it. Okay, you write prime because it's not factorable, all right, at that point. So right here, it's the difference of squares. So this is, I mean, anything with 2 terms, it's almost leaving it as memorization. Okay, it really is. So remember, difference of squares is just simply k plus 5 times k minus 5. Just plus minus. That's it. Okay? Do you guys all remember that? Esme, you got it? Okay, perfect. All right. That's it for that one. Next one. So that was this. Can anybody tell what this is going to be already? Is it going to be a... Well, let's just keep going with it. What's the GCF? Greatest common factor. 3 and what? Okay, so 3p cubed. So we're left with p squared. Now, you guys are going to have to help me out maybe a little bit. I know 3 goes into 180 60 times, right? So how many times does it go into the remaining 12? 4 more, so 64. Yep. 64, and then I've taken out the p cubed already. So that's what's left over. Hopefully, when you see this, you see difference of cubes again, or squares, difference of squares. So you have p squared, and then 64 is what squared? 8. So it's p and then 8. So then we've got p plus 8, p minus 8. Simple as that. Again, with the squared, you're going to have to remember some stuff. All right, we're good there? How much time do we have? Quite a bit. All right. Is anybody having trouble at all with difference of squares? Okay. So sum and difference of cubes. This is something that you're going to have to maybe take some notes on the side about. So let's go ahead and factor out the GCF on both of these real quick. So we're going to get them down to the same point. Okay, so this one. What's the GCF here? 3h to the 6th, and then we're going to be left with h cubed minus, we already did 192 divided by 3, and that was 64. 64, we took out h to the 6th, okay. All right, and let's factor this one out. What can I divide out of 16 and 250? Does 4 divide 250? Does 8? Does 16? Does 2? It'd be easy enough to start with 2. You know that 2 divides both 16 and 250, right? Because it's even. So let's just pull the 2 out real quick. I'm just going to write some side notes. So this would be kind of the way you wanted to do it if you didn't have a calculator. I'd divide 2 out of both 16 and 250, so I'd be left with 8 t to the 7th plus 125 t to the 4th. Is there anything else that I can pull out of 8 and 125? Can't pull out a 2. Could it be a 4? Huh? Oh, yeah, t to the 4th. Yes, absolutely. But let's just look at the numbers real quick. We're good with the numbers, right? Can't pull out a 2. Can't pull out a 4. Can't pull out an 8 of both of these. So we're good with the numbers. Like she was saying, we can pull out t to the 4th, though. So really all we can pull out is 2t to the 4th from both. So we're going to be left with 8t cubed, and then plus 250 divided by 2 is 125, and then t to the 4th is already pulled out. All right, so what are we left with here and here? Cube, right? So this is called the difference of cubes. This one's called the sum of cubes. Faith. Okay, thanks. Oh, I guess you already have your schedule. I got another one for you over here. I'll get it to you in a second. You just have a seat anyway. Actually, let's see. That's a spot, that's a spot. Which seats are typically open? That one right here, Ashley? Okay, Faith, you can sit there. So the difference of cubes, sum of cubes, right? They have two different formulas, but they're almost the exact same formula, so check it out. This is what I want you to write down. I mean, you can leave this too, but on the side where those lines are, where you can take some notes, I want you to write this down. Thank you, sir. Okay, so the difference of cubes, if you have the difference of cubes, so you have a cubed minus b cubed, you can write that down, and you can say equals if you want. I'm just not going to have space. So what that equals is, I'm going to erase this all in a second, but I want you to write this down. A minus b, okay, and then you have a squared plus ab plus b squared. These are just formulas. And then if you have a sum of cubes, you have a cubed plus b cubed. And what that equals is a plus b, a squared minus a b plus b squared. And those are your two formulas for sum and difference of cubes. Now, I mean, before I even erase this, let's talk about it real quick. Yes, sir. Sure. Ariana. And I think they need you. think they need you. Yeah. You need it right now?
Yeah, right now.
Okay. Here you go. Okay. So, guys, before I erase this, what's an easy way to remember this? Do y'all see how they did the exact same formula both times? And when I multiply it all out, do you see where the a squared is, or a cubed is coming from? The a times a squared? A times a squared. B, where's the b cubed coming from? B times b squared. B times b squared, right? So it's very obvious where a squared and b squared are coming from. And it's also very easy to remember between a squared, or a cubed and b cubed. And between the squareds, you just have an ab. It's a both. So that part's not very difficult to remember. Do y'all agree? I don't think that's very difficult to remember. It's just ab, then you have an a squared, a b squared, and in between you have a times b. Okay, we're good there? Wow. Yep.
Oh, I also need title about this.
All right. Okay, so now all you have to do is remember which ones are being added and subtracted. Where are your plus and minus signs? So if it's difference of cubes, you start off with a minus sign. That's a plus sign. If it's a sum of cubes, start off with a plus sign. That's a minus sign. That's the only difference. Okay? So it really shouldn't be that bad to memorize. But I'm going to go ahead and erase this. All right. And here we go. Okay, so this is a difference of cubes. So you have h times itself 3 times, and what times itself 3 times is going to be 64. So this is h times itself 3 times. What times itself 3 times is going to be 64? 4, right? So remember there's a way to find a cube root on your calculator. If you want help with that, I'll show you how to do that. But you can also think of it like, what's 3 times 3 times 3? 3 times 3 is 9, times 3 is 27. Okay, so that's too low. 5 times 5 is 25, times 5 is 125. Right, so you know it's between 3 and 5. We're probably not going to give you any decimals for stuff like this. Okay, so it's just a solid 4. Okay, so h and 4. So this is how you do it. That's your a, that's your b, by the way. Okay, so the formula was a minus b, so it's h minus 4, a minus b, times a squared, so h squared, plus a times b, so that's 4 times h, and then plus b squared, so that's 4 squared. So notice this looks real kind of intimidating, but it's not. And remember back to however many weeks ago, just a few weeks ago, we did this, right? It's not that bad. It literally is taking a and b and plugging it into the formula. Anywhere you see an a, you put an a. Anywhere you see b, you put a b. And that's all you're doing. That is all the formula that we just wrote out. Okay, we're good there? Let's do it one more time. Now this one is more difficult. I put this one up here intentionally. So you don't have to do it on your homework. I'm doing it for you right now. All right, so let's get this out of the way. This one's definitely more difficult. Okay, so let me go ahead and bring this down. 2t to the 4th. All right, so you're going to have a plus b, and then you're going to have all this stuff. Now the question is, what is a and what is b? That's what makes this question so difficult. When you look at this, what times itself 3 times is going to be 8t cubed? 2 is going to be 8, right? 2 times 2 is 4, times 2 is 8. What about the t cubed part? T, right? So this part needs to be 2t. That's the a value for 8t cubed. Does that make sense? 2t times 2t times 2t is 8t cubed. And then what times itself 3 times is going to be 125? 5 times 5 times 5. So that's your b. So now once you've got a and b, though, it's as simple as plugging it into this formula. So you should, because it's a sum of cubes, you have a plus b. So you have a plus b times a squared. So 2t. Now remember, this is 2t squared. Notice, guys, before you write anything down, look here. 2t squared, right, versus, and you tell me what the difference is. 2t squared. Yeah, right here, I'm just squaring t. Right here, I'm squaring 2 and t. Does that make sense? So what's 2 squared? 4. Okay. So that's what I wanted you guys to see. So 2t squared is 4t squared, like that. All right? Y'all understand? Because look at it one more time like this. 2t squared is 2t times 2t, right? 4t squared. It's just a common mistake people make. All right, and then it's going to be minus a times b. So what is 5 times 2t? Yep, I heard somebody say it. So 10t minus a times b, and then plus b squared. We got it? That's the sum and difference of cubes. So we did difference of cubes, sum of cubes, difference of squares, difference of squares. Sum of squares is not factorable, right? Exactly. We did trinomials. How much time do we have? Factor by grouping. Yeah, that's it. Okay. Next thing we could do is factor by grouping if we want. Might as well. Once I show you factor by grouping, you know everything at that point, okay? All the factoring. So factor by grouping. So notice we factored things with 2 terms. That's where we get difference of squares or sum or difference of cubes, right? 2 terms. We factor things with 3 terms. That's where we get trinomials, all right? And then we're now going to factor anything with 4 or more terms, okay? And the way you factor something with 4 or more terms is you actually break it into separate, kind of like breaking it into separate problems. And we call it factor by grouping because we're grouping parts of it together so we can factor it, all right? This is the most difficult type of factoring in my opinion. So here it goes. Factor by grouping. Now, the problems that the book gives you are pretty straightforward because it's already fairly well grouped for you, okay? So really, this needs to be grouped together and that needs to be grouped together. If it's not grouped for you, you might have to find a way to group it, okay? So for example, let me, on the side over here, I'm going to write it in just a different order. So if I have plus 6y minus 5y squared minus 30. If it's written like that, right, you actually have to realize that you need to switch these 2 places. So let's go ahead and start here, though. What's the greatest common factor of what we've put in parentheses here? Just y squared. So we pull out y squared. What's left over is going to be y minus 5. Okay. What is the greatest common factor of what we have in parentheses over here? So we have plus 6, and then what's left in parentheses? Okay, now, guys, catch what I'm saying right here. When you're factoring by grouping, this is what you're looking for. Does that make sense? Do you see how those are the same? Y minus 5, y minus 5? So what do we have then? We have 2 different things that are being multiplied by the same thing. They're both y squared and 6 are being multiplied by y minus 5. Does that make sense? So the final answer looks like this. Remember, when you factor something, you need everything multiplied together. Right now, it's not. You have these 2 things. You have that being added to this. But if you write it like this, y squared plus 6, y squared and 6 are both being multiplied by what? They're both being multiplied by y minus 5. And that's how you'd write it. Does that make sense? Mm-hmm.
So let's say instead of the plus sign, and between y cubed minus the first one that you took.
Yeah.
Yeah, instead of the plus, if it was multiplied, then would it be a binomial?
If it were multiplied, If it were multiplied, it would change it up quite a bit. It would make it easier, though, in a way. But if it were multiplied, you would look for what all of it actually has in common. So, would it make this a binomial, you're saying? Yeah, that would be a binomial. So you just treat it like a binomial. Okay? All right. Do y'all understand that? So notice what happens here, though. Watch this. I did this on purpose, all right? So let's assume that it's already organized for us, so we don't have to really think about it. We go ahead and group it without thinking. If we group that negative on the outside, what happens to that? Well, that needs to be a positive, okay? So make sure that because that negative, if I distribute it in, that's going to be negative 5y squared, and that's going to be negative 30, right? If I left that at a negative, then I distribute it in, and that would be a positive 30. And that changed the problem. But now, so let's go ahead and pull out what they have in common. So pull out a y, so we have y. We're left with y squared plus 6. You don't have to write this down at all. On this one, what would be a GCF that I could pull out? 5. So I'd have a minus. I pull out a 5. I'm left with y squared. Well, that actually worked out. Pull out a 5, yeah. That actually worked out. So we actually would be able to do y minus 5 times y squared plus 6 if we rearranged it, okay? But typically it doesn't break off until where we could factor by grouping like this again, all right? Typically, if it's not arranged the correct way, you won't actually be able to break it down like that. Okay, do y'all got it though? Y'all understand? Okay, let's go ahead and do one more factor by grouping. So this one, again, the book organizes it for you. So those are the ones that are supposed to be grouped together. Right here, I'm just going to go ahead and do it for you guys. 2k squared is pulled out of there, so we're going to have k and then minus 10. Everybody understand that? This one, when I factor out a 5, I'm going to be left with k minus 10. Again, this is what we're looking for, the k minus 10 to be the same. So we could write it like this. Both 2k squared and the 5. Both 2k squared and the 5 are being multiplied by k minus 10. And that's called factored by grouping. You guys got it? Okay, so 3 ways we've learned. We've learned factoring binomials, we've learned factoring trinomials, and factoring anything with 4 or more terms. All right? So with that being said, again, what you're going to be doing the rest of today, tomorrow, and the following day is doing every single problem, numbers 5 through 54. That's including all the odds. The answers are in the back of the book. Okay? If you want, I'll even go ahead and answer them as well. It's on page 236 of the book. All the books are stacked up back there. And you guys have 8 more minutes in this class, all of next class, and all the following class to finish those. Okay? Ooh, let's talk about, does anybody, before I turn this thing off, does anybody know the login for y'all's accounts online? You go to bigideasmath.com, right, /Northside ISD. So it looks like this. Actually, let me go ahead and do it like this. So we'll go here, big ideas. Okay. So I'm going to write this down because people mess this up. So I'm going to get it on recording too. So you want to go to bigideasmath.com/ I think Northside is all, Northside ISD, all lowercase? Yeah. Yep. Okay. / Northside ISD, uppercase ISD. And I wrote it up there a while back, but okay, good. Can you tell me what the username was so I don't have to figure this out again?
S number and then NISD.
Okay. Now, S number in ISD?
Yeah, but no
All right, and then the password was 4x4 all lowercase. This does work, okay? People keep coming to me and they're like, it doesn't work. This is typically why it doesn't work. Either they forget to keep the S off of the S number, right? Or the most common is they literally forget to put, it wants you to put NISD, lowercase, after your S number, okay? So if my S number was 1, 2, 3, 4, 5, 6, I would put in 1, 2, 3, 4, 5, 6, NISD. Okay, does that make sense? People think that it's just their S number. It's the S number with the lowercase NISD. Then leave the S number off, okay? You guys got it? Yeah.
It was one of the videos that you put on and you forgot to write the NISD.
Oh, and that's been messing people up?
Yeah.
Well, here it is. New video. Okay, maybe. I don't know if I'm going to put this on or not. But there it is. So if you guys want to get a head start on tonight's homework, or the next few days, then you can go ahead and do that.